Hey guys, today we're going over section 2A.3, which is combining like terms. This is, again, could be a review for many people, but it is such an extremely important skill as we go forward that I think it's important to go over it. So here we go. It's got a lot of vocabulary that we will use this year, and so I want to make sure we're clear on this. You can see the vocabulary in the box, and maybe at the end I'll come back to that. The first question here is, what are terms? Well, terms can be a number, you know, a number by itself like 3 or 10. A number by itself could be called a term. A term could be a variable. A single variable by itself, like x, of course, the most common variable used, or p. A single variable by itself is a term. Or the product of a number and variables. Remember, the word product in math means multiply. This is, so when I say the product of a number and variables, you could have a number times a variable or more than one variable, and all of that is a single term. 3 times x times y. That is a single term, just like the number 10 is a single term. Or you might have -7x squared y z. All of that is a single term. You can have as many variables and a number multiplied together, it's still just one term. Or you could have the basic, just 5x, a number times a variable. All of that would be a single term. Now, terms, all terms are one of two types. We have variable terms and we have constant terms. A variable term, shockingly, includes a variable, like 3 times x. 3x is a variable term because, that's right, it includes a variable. Constant terms, no variable, just a number. Like 10. 10 is a constant term. It does not include a variable, it just is a number. And the word constant is a fancy word in math for just having a number. All right, so we know what terms are. We know there are two different types of terms, variable terms and constant terms. This brings us to being able to name the parts of a term. So I have a term here, 3x to the second power. The 2 is called the exponent. The x is called the variable. And in a variable term, we have a special name for the number in front of the variable. The 3 is called the coefficient. Right? Let's see, let me write coefficient here. The number that the variables are being multiplied by is called the coefficient. Every variable term has a coefficient. Every variable term has a coefficient. Let me give you several examples. 1/2 x. 1/2 is the coefficient. Yeah, a coefficient can be a fraction. 1.3y. The coefficient is 1.3. Could be a decimal. -7x squared. Sure, the coefficient could be a negative number. Or the trickiest kind, a variable is written by itself, like just x, it has a coefficient. The coefficient is 1 because 1 times x is the same as just x. Now, we would never write it this way. We would really never put the 1 in front of the x when 1 is the coefficient, because x means the same thing, and basically mathematicians are lazy, and if we can write something in a simpler way, we're going to write it in a simpler way. So x, you just need to know that the coefficient is 1. There's a 1 in front of that, even if it's not written. Sometimes it's called the invisible 1 or the understood 1. And even a little bit trickier is when you have negative x. There you need to understand that the coefficient is negative 1. We will get back to seeing a little bit of that in a minute. All right, so this brings us to expressions. Now that we know what terms are, we can talk about mathematical expressions. Expressions are actually made up of terms. Each term is separated by a plus or a minus sign. Right? That's how you can tell how many terms are in an expression. Numeric expressions only contain constant terms, right? The word numeric means number. It only contains terms that just have numbers, constant terms. Algebraic expressions contain at least one variable term. Right? The word algebra means the use of variables. So I have an example here of an algebraic expression. Notice it's got 3 terms, right? 1, 2, 3. 3 terms that are separated by plus or minus signs. Anytime you see an expression, you should be able to name how many terms it has, and you should be able to name each term, which we're going to do. If I was going to list the terms that make up this expression, it would be x squared, 3x, and 5. Of those 3 terms, which ones are variable terms and which ones are constant terms? Right? Almost ridiculously easy. Variable terms include a variable, so that would be the first 2, x squared and 3x. And the constant terms would be the ones that do not include a variable, so that would be 5. And what are the coefficients? Well, the coefficients, right? Coefficients are only on variable terms, right? Only variable terms have coefficients. And all variable terms have a coefficient. It's the number sitting in front of the variable. So in our case, the x squared has a coefficient. It's the understood or the invisible 1. And the 3x has a coefficient. It's 3. Those are our coefficients. Real quickly, we're going to do 3 examples. If you want to pause the video for a second, try to write in the answers and then come back, you're welcome to. I'm going to go through this pretty quickly. In the first example, the variable is x, the exponent is 2, and the coefficient is -5. In the second example, the variable is w, the exponent is 3, and the coefficient is 17. And the last one, the variable is m, the exponent is 5, and the coefficient, it's that invisible 1 there, but it's got a negative in front of it. It's -1. Okay. So, now that we know what terms are, and we know what expressions are, let's look at multiplying terms together. How do we multiply terms together? Well, all you do is you multiply the coefficients together. And then you just tack on any variables. And an important note here is that any terms can be multiplied together. A simple example might look like this. 2x times 3y. You see this example is right here. I'm going to do it first. So 2x times 3y, remember that 2x means 2 times x. If I really wanted to write this out every step of the way, I could change this to 2 times x times 3 times y. And then I could say, all right, I'm doing all this multiplying. I'm going to rearrange the terms. I could put the 2 and the 3 next to each other and the x and the y next to each other. And then I could actually do the multiplying. 2 times 3 is 6, and I've still got times x times y. And a better way to write times x times y is just put them next to each other, and I get 6xy. Now, I don't need you to go through all these steps. I just say multiply the coefficients together and tack on any variables. So I multiply the 2 and the 3 together, and of course I get 6, and I've got the variable x and y, and I just tack on the x and the y. 6xy, or 6 times x times y, is my result. All right, let's go to the first one. 5x times negative 2. So I would multiply the 5 times the negative 2 and get negative 10. And then I've got that x in there also, be negative 10x. I'm just tacking on the x. In the second one, I've got negative 3 times 7mn. So I'd multiply the two numbers together, get negative 21 times m times n, which really just means tack on the m and the n. There's negative 21 times m times n. And the last one, ooh, look at that. I've got two negative numbers to multiply together, negative 5 and negative 4. That's going to give me a positive 20. And then I've got times g times h. And the best way to write times g times h is just tack them on, 20gh. Hopefully that's not too difficult. Let's move to the important thing, combining like terms, which is why we started this whole thing. All right, what are like terms? Like terms have a couple things in common. It's what makes them like. Like terms have the exact same variables. These would be two terms that have the same variables on them. Like terms have the exact same exponents on each variable. So the only difference when you have two terms, if they're going to be like terms, their only difference can be the coefficients. Variables got to be the same, exponents got to be the same, coefficients can be different. So the first job is, can you identify like terms? 3xy and 7xy are like terms because they have the same variables, x and y. Their only difference is the coefficient. Whereas 3x and 7y are not like terms because they have different variables. How do we combine like terms? Combining is a mathematical operation, and it means adding and subtracting. Combining always refers to adding and subtracting terms together. Now, only like terms are able to be combined. If you don't have like terms, you can't add them together. But if you do have like terms, you can. And the way you combine, which means add them together, the way you combine like terms is just add or subtract the coefficients, leave the variables and exponents the same as they are. Don't change the variables and exponents. Let's do a few examples. Again, if you want to stop the video, try them on your own, then come back and see if you got them. You're welcome. I think that's a good way to do it. All right, first example, 3m plus 4m. Yes, those are like terms because they both have just an m. So I add the 3 and the 4 together and get 7, and I keep the variable the same, m. Notice that the answer, 7m, would also be considered like terms with the two things you're adding together. It has the same variable and exponents. 6x minus x. You got to remember that second term, the x, does have a coefficient, even though it's not written. It's a 1. So what you're really doing here is 6x minus 1x. Add or subtract the numbers. The 6 minus 1. Obviously, 6 minus 1 is 5. Keep the variable the same. 6x minus 1x is 5x. All right, now we get to some examples that have more than one term. You might remember a couple sections ago when we talked about adding and subtracting. I like to circle the things I'm adding and subtracting. I think that especially helps when you're adding and subtracting like terms. I like to look for the like terms and circle them. And notice how I include the sign of the term inside the circle. So this helps me add and subtract better, I guess. I'm looking at 3x squared and negative 8x squared. So am I going to add those and get 11, or am I going to subtract 3 and get 5? Well, because they have different signs, I noticed subtract. This would be 5. And because 8's the bigger number, it's going to be negative 5. Remember? And then I keep square. When you add and subtract like terms, don't change the variables. And then I've also got positive 4x and positive 5x. Those guys are like terms. They both have the same sign, so I'm going to get 9x. And they're both positive, so the bigger number is positive. There's my answer. Negative 5x squared plus 9x. Of course, those cannot be added together because they're not like terms. Since this has an x squared, and this only has an x. The next example D. My like terms are the 7x and the 3x. Positive 7 and positive 3 adds up to positive 10. And I don't change the variable. And then I've got negative 11 and negative 4. Again, those have the same sign. So when I add or subtract, since they have the same sign, I'm going to add them together and get 15. And I need a sign in front of that 15. And of course, when I'm adding or subtracting, the bigger number always gets sign on the answer. 11's the bigger number. He gets to put that be a minus 15 or a negative 15. Next example. E. I don't see any like terms. The first term has an x squared. The second term just has an x. The third term doesn't have a variable at all. None of them are like terms. So there's nothing you can do to simplify that expression any further. Your answer is the same as the problem. And last up, I've got these. How many terms are there? Let's see. 1, 2, 3, 4, 5. I've got five terms, and I'm looking for like terms to combine. Well, the first ones I see are negative 2x and negative 5x. Again, I'm adding or subtracting. Since those have the same sign, I'm going to add them and get 7x. And the bigger number gets to use his sign. So he gets to use his sign. And I have successfully combined those. And then I also have three numbers. Now all three of those are like terms. So I can combine them all. I'll start with the positive 13 and the negative 15. Would I add those and get 28? No. Different signs. Different signs would be subtract 15 and 13 and get 2. And 15 is the bigger number, so it's negative 2. And then I need to combine my 1 and my negative 2. Those had the same sign. So I'm going to add them. When you add them, same sign means add. You get 3. 2 is the bigger number. He gets to put his sign. It's negative 7x minus 3. Good luck.